All right, let's talk about linear relations and functions. We're talking here about notes 2-2, and we're rolling. Key concepts here in the second sentence. Relations that have straight line graphs are called linear relations. We talked a little bit about that at the beginning of lesson 2-1. Relations that are not linear are called non-linear relations. How about that? That's pretty obvious. Now think about those linear relationships. An equation such as x plus y equals 5 is called a linear equation. A linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. Okay? Now, take a look at the next line. It says the variables may not be multiplied together or appear in a denominator. So I'm going to underline that with my pen tool. They may not be multiplied together or appear in a denominator. Okay? A linear equation does not contain variables with exponents other than 1. An exponent of 1 really doesn't do anything. X to the first power is just x. So the graph of a linear equation is always a line. So let me highlight that. So of course the graph of a linear equation is a line. It's a straight line. The linear equations can look like this. 4x minus 5y equals 16. X equals 10. Y equals negative 2/3 x minus 1. Y equals 1/2 x. Now on the other side, these nonlinear equations, notice this one has a variable that's not a 1. It's a 2. That's not going to be linear. It's going to be a curve. Okay? This one here, y equals the square root of x plus 2. The square root is actually an exponent of a half. And then down here we have x times y. You can't have variables multiplied together if you're going to have a straight line linear function, linear equation. And you cannot have a variable in the denominator. So those are examples that are not linear functions. Okay, so let's roll up here a little bit in our note sheet here. So linear function is a function with ordered pairs that satisfy a linear equation. Linear functions, linear equations, they're related. Any linear function can be written in this form. We talked about this the other day, this f of x, this function notation. And m and b are real numbers. Now you might recognize this. We're going to talk about this in another lesson, but hopefully you remember y equals mx plus b, which is what? Slope-intercept form, where m is the slope and b is the y-intercept. So if you can see the relationship here between what you already know and y equals mx plus b. All right, let me slide up. Move this up here. So in this section, you're supposed to state whether the function, the equation, is linear or not linear. So let's take a look at the first one, f of x, 8 minus 3/4 x. That definitely is a linear equation because it fits what it says up in our top part here. It fits the idea of linear equation. It doesn't have one of these exceptions that would be nonlinear equation. Go to B. Notice B would not be because it has a variable in the denominator. So I'm going to use the green. So this is not going to be a linear. All right, the next one, g of x and y. You're going to put in an x and a y. Here's the equation, 3 times x times y minus 4. We can't have two variables being multiplied and be linear. So go to my highlighter. That also would be a no. Okay? So look down at number 1A. What do you think about this? Well, the variable is in the denominator, so that definitely would be not a linear relationship. That's the key here. Now look at 1B. 1B, look what it says. You have the variable times negative 3/2 plus 1/3. That fits that mx plus b. That doesn't have any variable in the denominator. It doesn't have variables multiplied times each other. It doesn't have an exponent more than one. So that is going to be linear. I'll highlight that with my yellow. Okay, on the back of that first page of notes, on the back, we open it up, on the back there, it has a real life example of where this can be applied. It's talking about the growth rate on a sample of Bermuda grass. So people go to Penn State a lot for turf management, for how to take care of outside, like landscaping, that kind of thing, and the grasses. And here's the function. And notice that function definitely is linear. It's in that mx plus b form. And all you need to do is then apply. They want to know, what does it say here? How tall is the sample after 3 days? So you put the 3 in the function where x, here it says x is the number of days, and the f of x is the total height of the grass. So you can actually calculate how high this grass is. So you have all these mathematical equations set up so they can measure the heights of grasses, believe it or not. And you notice that you just substitute in the 3 for the x, and calculate the output, which is 20.95 inches in 3 days. That stuff grows fast. Holy cow. So maybe a lot of golf courses would use that, or maybe not. So you notice there are applications that deal with linear functions. Okay. Now a lot of linear relationships are not common. A lot of times there are curves, other types of relationships, like I mentioned in physics. We have a lot of curves like sound waves and trajectories, which aren't straight lines. All right, let's slide to the third page, the front of the second sheet in the note packet. It's talking about standard form. This is something that we should be familiar with, standard form. We have this concept box, and the idea of standard form is you can write any linear equation in this form. If it's linear, a linear equation, a linear function, it can fit this form. It doesn't always have to look like that, but you can turn it into that. It's ax plus by equals c. And it's important to understand that the a, b, and the c, as it says here, the a, b, and c, they're integers. You don't want any fractions or decimals there. And their greatest common factor is 1. And the a must be greater than 0, so you can't have a negative in the front. You have to manipulate that and use some algebra to make it fit that. And if it doesn't fit it, then it's not linear. Okay? And a and b cannot both be 0. So you can't have the a be 0 and b be 0 at the same time. Okay? So here's an example of standard form, 3x plus 5y equals 12. Now again, not every equation is going to look like that. So if it's linear, you should be able to use algebra skills and change it to the ax plus by equals c form. That's what we're going to practice next. Scroll up here. You can see the example that they did here, example 3. Negative 3 tenths x equals 8y minus 15. You want to write it in standard form. And they are doing what first? They're going to be multiplying both sides by 10 because they want to get rid of the fraction. The denominator right here is a 10. So when you distribute, the 10s would simplify. You'd end up with 3x. Oh, notice they actually multiply by negative 10. Okay? Negative 10 on both sides, which gives you a positive 150, and it gets rid of the negative in the front. You can't have a negative 3 there. The a has to be a positive. You remember from up top here, the a has to be a positive, it has to be greater than 0. or it could be equal to 0. And then let's see what we got here. Oh, I missed one part. In the very beginning, they moved the y's to the other side by subtracting 8y. It doesn't look like an 8, does it? But you subtract 8y to both sides. That's why now it's now over here when it used to be on the right side. So you need to have the x's and the y's on the same side. And then finally, you got to look for any common, least common multiple. But this 380 and 150, you can't divide anything out of all of those, so you are done. We're done, and this would be called standard form, where the A is 3, the B is 80, and the C is 150. We're going to apply that idea to 3A. So how do you change this equation to standard form? I need the x's and y's on the same side. So I'm going to subtract 4x on both sides. And when I subtract 4x on both sides, I get negative 4x plus 2y, because adding negative 4x is the same as subtracting 4x. Apply your algebra skills. These cancel out, I get 5. Does that look like a standard form? Ax plus by equals c. It looks close. I can't have a negative at the front for the a, so I'm going to multiply both sides by negative 1. And when you distribute, I get 4x, then I get negative 2y, and the other side I get negative 5. And that fits, this fits the idea of standard form. And it has to fit what we talked about here, where a, b, and c are integers, and the greatest common factor of a, b, and c is 1, a is greater than or equal to 0, and a and b can't both be 0. Fits all those criteria. So the last one, b, we'll look at. We have the x's and y's on the same side. See that? But we need to get rid of this minus 9. And how do you get rid of subtracting 9 by adding 9? So let's add 9 to both sides. So I have 3x minus 6y equals 9. Are we done? Looks like we are. We have an ax. You can say plus, because you can change that to adding the opposite. by equals c. But there is a common factor you can get out of there. You can divide. You can get rid of a 3 here. So you can divide both sides by a 3. So you get 3 here. And division, since it's really just multiplying by reciprocal, you can distribute it like multiplication. So you're going to divide the 3 into 3. They cancel out and become 1x or x. And then you look at the negative 6 and the 3. They would simplify, and this becomes negative 2y, so plus negative 2y. Now that's in standard form. You could then rewrite it to be like this if you wanted. But the idea of addition, ax plus by equals c, and it has to fit what we talked about here in the key concept box.